Hello, this is Mrs. Huntley. We are in Module 1. We are finishing up the first topic, which was the properties of exponents, and we're beginning our review for the summative assessment that's coming up. So this is your video 5 or your lesson 5, the beginning of a review. Now you should have gotten this sheet of paper. It's a single sheet of paper that has the laws of exponents on it, and we're going to create a graphic organizer. Now in class, I asked you to fold it kind of hot dog style where you're making a crease along this edge here where the dotted lines are and along this edge here. Not envelope style. We don't want them overflapping in the middle. We want them to kind of meet in the middle. So after you fold it, your edges of the paper should meet in the center here, and you have a crease on this side and a crease on the other side. And what I'm going to ask you to do is get a pair of scissors, and you're going to cut from the center into the crease so that you're creating little doors so that behind the flap that says definition of exponents, we can have the definition and we can have some examples. I hope that makes sense to you. I know we talked about it and I showed you an example in class. And if my overhead would work at the same time as the video recording, I would show you what I'm talking about, but we still have a ticket on that trying to get that fixed. So at this point, all I can do is explain it the best that I can and hope that you get it. If you're confused at this point, pause the video and send me a text, and I will see if I can explain it maybe a little bit more eloquently. Moving right along, definition of exponents. So the open flap part, you're going to write the definition of exponents is a shorthand for showing repeated multiplication. What does that mean? Let's do an example. So I'm going to make that a little thinner. If I have, let's say, 5 to the third power, 5 is my base, 3 is my exponent, and it means 5 times 5 times 5. So it's showing that repeated multiplication, but it's a shorthand way of showing it. We need to know what a base is. We need to know what an exponent is. No, there's not going to be actual vocabulary on the test, but you need to know those terms, those mathematical terms, so that you can follow the directions that they might be asking you to do. Next one, product of powers. That's on the right-hand side, so you're going to open up that right flap. And what is the product of powers? It's multiplication of exponential terms. We may not have called it product of powers in class, but that's what the graphic organizer is calling it. So if you're not sure what we're doing, it's multiplication of exponential terms. And the definition, if the bases are the same, keep the base and add the exponents. So again, let's go with x's. So if I've got x to the third power times x to the fourth power, that's going to equal x to the 3 plus 4 power, or x to the 7th power. And that would be my final answer. Hopefully this is ringing bells for you and you're like, oh yeah, review, cool. Next one, negative exponent. That means we're going to take the reciprocal to make the exponent positive. So if I have x to the negative 4th power, taking the reciprocal of that would be 1 over x to the positive 4th power. Similarly, if I have something like, let's say, a to the 3rd power over b to the negative 4th power, I want to move that b to the negative 4th power into the numerator. So it would be a to the 3rd power, b to the 4th power. So wherever it is, if it's in the denominator, it's going to move up to the numerator. If it's in the numerator, it's going to move down to the denominator. Power of a power. This is something that we just recently did. What does it mean? You multiply the exponent on the outside of the parentheses by all of the exponents inside of the parentheses. So if I have x to the 3rd power all raised to the 2nd power, what this means is I'm going to have x to the 3 times 2 power, or x to the 6th power. That's how I would do that one. Zero exponent, any value raised to a zero exponent is equal to 1. So I could have x to the 0 power, that's going to equal 1. I could have, I'm looking for that really involved one that we had in class. That was so fun. Oh, and I should have had it available to me before I started this, but let's just go 3x to the second power all raised to the 0 power, that's going to equal 1. That's not as complicated as the one that we had in class. But anytime something is raised to the 0 power, regardless of how complicated it might be, it's going to be equal to 1. Quotient of powers, this is the division of exponential terms. So again, if your bases are the same, you're going to keep the base and subtract the exponents. So if I have something like x to the 6th power divided by x to the 3rd power, I'm going to have x to the 6 minus 3 power, or x to the 3rd is my answer. Moving along. Product of a power, if there are multiple terms being multiplied together inside a set of parentheses or brackets, the exponent on the outside of the parentheses is multiplied by all of the exponents inside the parentheses. So let's take a look at what this means. If I have something like 4a to the 3rd power times 3b to the 7th power, all raised to the 2nd power, this 2 is going to hit everything inside those parentheses. So I'd have 4 to the 2nd power, a to the 3 times 2, or 6th power, times 3 to the 2nd power, b to the 7 times 2, or 14th power. Now, I could multiply my 4 and my 3 together because they have the same exponent here. So I could say that this is 12 to the 2nd power, a to the 6th power, b to the 14th power. But honestly, if you get here, I'm going to be happy. Just know that whatever is on the outside of the parentheses has got to hit everything on the inside of the parentheses. And these coefficients can be multiplied together as long as they are raised to the same power. So technically I could have multiplied them together here and had 12, and then that 2 would have to hit it. So I can either multiply them first or multiply them last. Okay, quotient of a power. So if there's a numerator and a denominator in parentheses with an exponent on the outside of the parentheses, the exponent needs to be applied to both the numerator and the denominator. So if I have x divided by y, and it's all being raised to, let's say, the 6th power, just making it up, that's going to be x to the 6th power divided by y to the 6th power. Similarly, I'm just going to give you another example here. If you don't have room for it, don't worry about it. But if I have like 2x to the 3rd power being divided by y to the 2nd power, all raised to the 2nd power, that's going to be equal to, that has to hit everything inside again. So it's going to be 2 to the 2nd power, x to the 3 times 2, or 6th power, divided by y to the 2 times 2, or 4th power. And that would be my final answer. So again, has to hit every term. If there's an exponent greater than 1, you've got to multiply them. If the exponent is 1, it just kind of attaches to everything that's in there. Okay, and this is the study guide, which you will get in class tomorrow. So I'm going to end the video here, only 10 minutes. I realize that you probably had to pause it here and there to make sure that you got all of those definitions down, because writing things is a lot slower than speaking things. So, but hopefully you didn't spend too much time on it. If you have some time and you have some of the mixed practice that was on either the worksheet that you got in class today or the worksheet that you got in class yesterday, you can feel free to go ahead and work on some of those. We are going to work on some additional practice in class tomorrow, and it never hurts to go back and just be practicing the skills that we have, even if it's not specifically assigned. So I'm going to sign off here. Have a great evening, and I'll see you tomorrow.